welcome once again. My name is Timson. Last class we discussed the introductory. We did the introductory part, in the introductory, excuse me, part of data science. Excuse me. We discussed much about what data science is, the concept, and the subset of data science. We discussed machine learning. We discussed traditional data engineering, and of course, we even discussed what data is in general. You know, so we talked. We made use of infographic um, material to depict several meanings, to explain several concepts, and today we're gonna be talking about probability right now. Uh, you might be wondering probability. So, what is probability? Like I told you, that data science, comprise of consists of statistical, mathematical applications. But that shouldn't create some kind of fear, or that shouldn't scare you. It's not something that you should be worried about. In fact, you get to understand that you were not being taught rightly in your previous days in schools. You know, I'm not trying to hype myself something, but I'm just trying to tell you that, you know, uh, let me just not say further than that, anyways. As we know that in our everyday life, we are faced with various uncertainties, and we most often ask ourselves in our daily endeavor that, one, what is the probability that we succeed, or what is the probability that we fail? These questions forms our decision as to, okay, whether a particular risk is worth taking. Organizations, firms, or any other corporate entities you may think of need this decision to determine whether to venture into certain risk rather. So probability and statistical data are very useful tools needed to employ in such decision makings. you know so some of you might be wondering, what is this probability anyway? Uh well, it is a chance of something happening. It's a chance of something happening. That's the best. In fact, that is a simplest layman definition you can give to what probability is. But is this definition okay? Is it accurate? Well, it may be accurate in terms of pedestrian knowledge, in terms of you know layman knowledge, but um, statistically, it is not complete, in such that we need to give it a more academic explanation. And how do we do that? We can just simply say, uh, to give it a more academic definition, we'll say something like, it is the likelihood of an event occurring, which is this, a likelihood of an event occurring. And you see, this word event is a very important term in the definition. The likelihood of an event occurring. And if you take a look at the each of the meaning of these words, each of the meaning of these words, uh, you would see that it correlates, or it corresponds with uh, the previous definition I gave, which is, say, um, the chance of something happening. But for the sake of convention, for the sake of mathematical or statistical convention, we will stick to these terms, this definition, because of these terms in particular. So this term event rather, you know, we should be more particular about it. So what is an event? When you say event, well, you might say event is an occurrence. You might say event is something uh, something that precipitates history. Well, that would be when you are trying to talk to laymen, or when you're trying to give the definition to um, pedestrian, when you're trying to give pedestrian information or pedestrian definition. But here we need to be more profound. So what is this event? If you are being asked academically, what is this event in the definition of probability, well, today you will know. You might not know, but today I bet you will know. You see, when you talk about event, the term event here has a definite meaning. it could mean a specific outcome or combination of several outcomes. Let me write it here. Let me try and zoom a little bit so that uh um to have good visual. Sorry. Okay, it's not zooming anyways. Okay. I think it's clear enough. If I'm not if it's not clear enough, please let me know. So let's say we can give a definition like say um, okay, let me say a specific outcome. Event is a specific outcome. Event is a specific outcome. Specific outcome, or say uh combination of several outcomes. Combination of what several outcomes. So it could be a specific outcome or combination of what several outcomes. So these outcomes could be one. Let me say these outcomes could be one. Say getting ahead. Let's say getting ahead from what tossing a coin. From tossing what a coin. And when you toss a coin, the probability of you getting ahead is an event. You know, um, you see, from the combination of several outcomes, a specific outcome or a combination of what several outcomes. So, one example of these outcomes could be getting ahead from tossing a coin. Another one could be getting a four. Let me say two. Let me say getting a four. Getting a four. Excuse me. Getting a four from getting a four from uh rolling a die. No, when I say die, it means I'm talking about dice. It's a singular form of dice. You understand? So getting a four from rolling a die. Then another one could be say um getting to getting to a specific location to a specific location. Getting to a specific location. Uh, Getting to a specific location, say under um, under a specific under a specific period of time, period of time. So we have one getting in ahead from tossing a coin. Two, um, we have two, we have one. I said getting ahead from tossing a coin. Two, getting a four from rolling the die. Three, getting to a specific location under what specific period of time. Let's say you're trying to get to from Lagos. You're trying to get to say Abuja for you are trying to get to Abuja for a period of say you want to spend, what is the probability of getting to Abuja within 8 hours? That is what the number three is trying to talk about. Then that being said, uh I hope you get a drift of what I'm trying to say. Then let's first of all, let me try to deal with this number one, this getting a head from tossing a coin. So flipping a coin, you will agree with me that when you flip a coin, there is a probability that you will get one side out of the two possible sides. A coin has two sides. A coin has two sides. It's either a head or a tail. I want to assume you know understand that. So when you have a coin, is that you either have a head or a tail. One side is called head. Say, let's say I don't know if any of you have seen the old 1 naira coin. So if you have old 1 naira coin, the place where you have the image is called the head most often, and the place where you don't have the image, the other side is called the tail. Let's assume, of which it is always so. So the probability that you get one side, the probability that you get ahead, of course, out of the two possible sides. So when you say uh you are when you flip a coin, there's a probability that you get one side out of the two possible sides. It could either be what? A head or a tail. That means we have two possible events. So if you have a coin, for example, let me reiterate. If you have a coin and you want to flip the coin, there is a probability that you either get what? A head or a tail. And that probability, because you cannot get the two sides at a time. You only get one side when you flip a coin. You can't get the two side. You only get one side. You know, and there are two possible sides. So the probability of getting one side, either a head or a tail, that means we have two possible events. So the two possible events could either be a head or a tail, and we need to assign probability to each one of these events. So how do we assign probability to it? Note that we can assign probability using percentage. Say for example, say for example, uh, say 20%. You understand? Or say 1 over 5. You understand? So how did I arrive at 1 over 5? Now, when you hear the word percent, anytime you see the word percent, what precedes the percentage sign or what precedes the percent must be what? Divided by 100. Say, for example, this is what I'm saying. Say you have a percent. Okay? You have a percent. So a percent simply means a divided by what? 100. That is it. So in this same line, in this same context, 20% will be what? Will be what? 20 over 100. Whatever percent you have must be divided by what? 100. So when you divide 20 by 100, when you cut this 20, you have what? This 20 here, when you slash it, how many 20 can you see in 100? You have what? 5. How many 20 can you see in 20? You have 1. How many 20 can you see in 100? You have 5. I hope you understand this. That is how we got to this 1 over 5. 20%, remember I told you anything percent is that thing divided by 100. So in this same context, if we have 20%, it's same thing as equals what? 20 all over what? 100. And 20 divided by 20 is 1. 20 in 100. How many 20 can you find in 100? 5. So 20 divided by 100 is same thing as what? 1 over 5. You understand? But in this case, to follow a statistical convention, we don't use we don't use percentage. You could use it, streetwise you can use percentage, streetwise you can use uh, fraction. But to have a more accurate statistical calculations, so by convention we use float or decimal point. Sorry, float is a lingo, it's a programming lingo, it's a programming lingo that we often use to term uh, decimal point or decimal value. So we use decimal point, and in this case we have, if you punch your calculator and divide 1 over 5 or 20 over 100, you will have what? When you divide 1 over 5, you will have when you say 1 over 5, you will have what? 0.2. So you can punch your calculator, you can use your phone, try to find your calculator. Of course, if you're on a system, you can just go to Google and search for calculator, you will see it there. So that being said, now, the simpler way to measure probability, we can use a horizontal line. Say, a line like this. Sorry. Let me try to look for a good line here. Let me, excuse me. Shapes, lines. Okay. Say, so to depict. Okay. I'm coming. Shapes, lines. So, yeah, I said the simpler way to measure probability is we can use a horizontal line to depict it. Now, this is a horizontal line. Let me say, yeah, This is the horizontal line. You understand? So here, the value in the value here, let me put another shape, say another line. The value here is what? 1. And the value here, sorry, excuse me. And the value here is also what? No, sorry, the value here is 0 and the value here is what? 1. So here you have what? Here you have here you have 0 and here you have 1. So when the value, the probability falls is on 1, it means it is an absolute certainty that the event what occurs. It is no more probability, it is what? Possibility. When your probability now falls to 1, the probability, when the probability becomes 1, it becomes what? Possibility. Sure, you understand? So it is an absolute certainty that the event what is that the event was occur. You understand? A probability value at 1, if a probability values to 1 or if a probability equals to 1, it means what? An absolute certainty that the event has occurred. It becomes what? Possibility. And if a probability equals what? 0, which is here. I told you it's an horizontal line between 0 and 1. So if a probability falls to 0, it is an absolute certainty of the event not occurring. It becomes what? Impossibility. You understand? So we have 0 impossibility, we have 1 possibility. That is the probability of an event, the absolute certainty that an event occurs, the absolute certainty that an event is not does not occur. So between that 0 and 1, what is inside here is what? Probability. You have impossibility, you have possibility. Between impossibility and possibility, you have what? Probability. So it is suffices to note that probability finds itself between 0 and 1. If it is 0, it is impossibility. Simply means an absolute certainty of the event not occurring. If it is 1, it is what? Probability, I mean possibility. That is the absolute certainty that the event is what? The event will what? The event what occurs. So in between the two is what? Probability. Remember, impossibility, possibility, in between them is what? Probability. And of course, impossibility is what? Is 0 and possibility is what? 1. So don't forget that. So it's quite obvious that the value between 0 and 1 represents what? The probability. So note that the higher the level of probability, the higher the likelihood of an event occurring. Meaning from here uh, to this half, it is it shows the lower of the probability occurring. The lower it shows the likelihood of the probability not occurring because it is lower. So the closer to 1 shows uh, the significant likelihood of an event occurring, the higher likelihood of an event occurring. So as the event gets closer to 1, it shows the chances getting bigger, getting bigger. You understand? There is more chance, the probability is getting towards possibility. So it means the likelihood of an event, the higher likelihood of an event occurring. And if it is tending towards 0, it is the lower likelihood of an event occurring. Please don't forget that. So that is to say, as the number moves towards 1, then the higher the likelihood of an event occurring. As the what? As the number moves towards 1, it increases the chance of what? The likelihood of an event occurring. As it tends towards 0, it reduces the chances. That is the lower the chances. Please don't forget that. Then now let's get this definition in practical. Let's say let me use this sorry. Let's say um let's say A is an event, let's say A is an event. It's an event. Let's say A is an event. You understand? Let's say A is an event. So if A is an event, uh that is A equals what? Event. Let's say A is an event. Hmm? And of course, to get the probability, it will not be what? It will be what? P of what? A. P of where A, abi? So the probability of A means what? Probability, right? Let's say P of A means what? Probability. It means what? Probability. So how do we get the formula for P of A? Because A is the event. P of A is what? The probability of what? Event. So to get the probability of A, that is P of A, to get P of A, it will now be what? Equals to the number of preferred outcome. The number of what? Preferred outcome. Preferred outcome. The number of what? Preferred outcome. All over what? Total number. Total number. All over what? Total what? Number. You understand? Now, probability of A, you understand, equals what? The probability of event. I told you A is an event. So the probability of an event, which is the probability of A, equals what? Equals uh, number of preferred outcome all over the total number of what? Outcome. All over the total number. Let's say. So by number of preferred outcome, I actually mean the number you want to see happen. And in statistics, we call this what? Favorable. This number of outcome, number of preferred, we call it in statistics, we call it what? Favorable. Favorable outcome, which is what? The favorable outcome. Now, uh, by total number, we mean this total number, we mean say we mean I want to put it in a simple term. We mean everything available to select from. So in statistics, we call this one, this total number, we call it sample space. Let me use a real life scenario. For example, I have a bag of five orange. I mean, sorry. Okay, let's say I have a basket of five oranges, and you begged me for, and the bag of those oranges consist of the basket of oranges consist of, say, two ripe orange. Let me say mango. I have a basket of five mangoes, and the basket consists of two ripe mangoes and three unripe mangoes. Now, peradventure, we saw, and you begged me for um ripe mango, say two ripe mangoes. You understand? So after seeing that I have a basket of five mangoes consisting of two ripe mangoes and three unripe mangoes, then I decided to blindfold you while I ask you to pick from the basket. So the probability of you picking the ripe mango is what? Your favorable outcome. That is what you want. Your favorable outcome. That is called your favorable outcome, number of preferred outcome. You see, it is because you want two ripe mangoes. So that is what you want. So the probability of selecting what you want, that is favorable outcome. Which you want to, I said the favorable outcome is the outcome you want to see what happen. Why the total available mangoes, that is five mangoes, is what? Called sample space. So sample space is the total available the total available outcome, while the favorable outcome is the number of outcome you want to see happen. You understand? So let me use another example. Let me use a coin. You know, let me use a coin as another example. Say you want to flip a coin, and you know a coin has two sides, a head and a tail. You understand? So the probability of getting a head is your what? Favorable outcome, of course. And the total outcome is what? How many sides? Two. You understand? So what you want to see happen is your what? Number of preferred outcome, which is called favorable. And the total number of the outcome is called the sample space. So in this case, the sample space of a coin will be what? The two side, which is what? Two. And the total, the number of preferable outcomes, say you want a head when you toss a coin, is what? A head, which is what? One. You understand? So P of A, if the event is what is called is a coin, P of A in this case will be number of preferred outcome. Of course, can only have one head in a coin, so one all over total number of what total number of outcome, which is of course two sides. That is the sample space, which is what? Two. Hope you get what I'm trying to explain. So that is that. So in this case, we can now say because it's a coin and it has two sides, probability of an event in this case will be what? 1/2, which is equivalent to what? If you put in your calculator, is equivalent to 0.5. I hope I'm clear in this case. So if you still have a question as to this, please, I need your comment, or I need you to write in the comment section. So let's say we want to use another one, say they die. Now you have the possible outcome of a die. The total number of outcome in a die is what? 6. And you want to say, let's say the probability of you want a 4. You understand? The probability of you getting a 4 will be what? 1 out of the 6, possible, 4 possible side of a die. A die has 6 possible side. You understand? 6 total outcome. Let's say you've seen a die before, I believe, and a die has, if you are playing Ludo, the die, it has 1, it has 2, it has 3 side, then the side that is 3, it has 4, it has 5 and 6. So the probability of getting any number is that number, that your preferred number, divided by the what? The sample space. And I told you the sample space is the total available outcome, while the number of preferred outcome is known as your favorable outcome, is what? Is also known as the outcome you want to see what happen. Please don't forget. And in this case is 1/6. You understand? Let's say if you want to go further than that, and you want to say, if you want to get something like a number divisible by 3, let's say from a die, we have 1 dot, we have 2 dots, we have 3 dots, we have 4 dots, and according to the side, we have 5, we have 5, we have 6. You understand? Now say you want a side that is divisible by 3. What do I mean by divisible by 3? I mean when it is divided by 3, there is no remainder. You understand? So in this case, you have 3 is divisible by 3 without a remainder. And also we have what? 6. 6 is also divisible by 3 without a remainder. 6 divided by 3 will give you what? 2. So we have two um in this case we have uh two preferred outcome. You understand? Two preferred outcome. And in this case, because it is 2, it is no more 1, the probability will now be what? 2 preferred outcome all over what? The total of what? Outcome, which is what? Divide 2 by 2, you have 1. Divide 6 by 2, you have what? 3. So in this case, you have 1/3, which is equals to what? Which is equals to equivalent to 0.33 in equivalence. You understand? And 1/6 is equivalent to 0.16, I guess 7. You can use your calculator for that as well. So that being said, going forward, note that the probability of two independent events occurring at the same time. Now, I don't want you to get confused here. You know, before now, I said the probability of an event occurring. Now, in this case, let's go further. Now, let's say two independent events occurring at the same time. At the same time, how do you get it? Say you have probability of A probability of A and what? Let's say no, sorry, probability of A, uh, probability of A, okay, probability of A times probability of B, or probability of no, sorry, let's go. Excuse me. Let me clean it off. Let me say probability of uh A and B and B uh equals what? Uh equals probability of A times probability of what? B. You understand? So these are two independent events. By independent events, what do we mean by independent event? Let me first of all give the definition of how to find the formula for probability of independent event. So note that two independent events occurring at the same time, the probability of it is the multiplication of the two probability. For example, P of A, this P of A and B will give you what? P of A times P of B. You understand? These two events are independent, but they are occurring at the same time. Get the definition. The probability of two the independent events occurring at the same time, happening at the same time, is what? Probability of the first event multiplied by the probability of the second event. They must be independent and they must what? Occur at the same time. You understand what I'm saying? Let me give an example of what I mean. Let me further explain what an independent event are. Say, uh let me give it a good definition. Let me try to, okay, let's say it's an event that if an event don't influence one another, so this event is not influencing this, you understand? Or let me say it does not have any effect. This probability of this A, event A, is not having any effect on what? Event B. Let's say, for example, taking a taxi and getting a free meal at your favorite restaurant. They don't correlate. Taking a taxi ride and getting a free meal at your favorite restaurant. Say taking a Uber ride and getting a free meal at your what favorite restaurant. Or let me say uh uh, winning a card game and what? Running out of bread. So let me say the probability of, let's say the probability of taking a taxi ride and getting a free meal at your favorite restaurant. There are two independent events. So the probability of getting that will now be probability of what? Taking a free ride times the probability of getting free meal at your favorite restaurant, is because they are two independent events and they are occurring at the same time. So you multiply them together. Note, they must be two before you can do this calculation. The question must say there must be two independent events, meaning event A does not have anything to do with event B, and they must what? Occur at the same time. So you use this formula. That is that. That is that. So let's say the probability of winning a card game and running out of bread. The probability of getting that will now be probability of winning a card game times probability of what? Running out of bread. Get that straight. Thank you. Now, later on, I'm still going to define some more concepts of independent event, so as for us to have a deeper grasp of what I'm trying to say. For now, let's examine more examples of probability. What about the probability of winning, say, I don't know if you know, there's this popular lottery or lotto in Lagos called Baba Jebu. I don't know if you know that. So, what's the probability uh, of winning Baba Jebu in Lagos? For example, it's a popular lottery in Lagos or lotto in Lagos. What's the probability of winning Baba Jebu in Lagos? Well, in this case, the preferred outcome will be the amount of tickets, you bought, the amount of Baba Jebu ticket that you bought or you played. You understand? Now the total possible outcome will now be total number of tickets that have been played, because they are going to pick, let's say they are going to pick a number from the number of tickets you've played. They are going to pick a number, random number. So let's say uh Let's say you played one ticket, mm, and uh, the total number of people that played, or the numbers they are taking from, is 20 million. You understand? So the probability of that would be P of A, probability of that event equals one ticket that you played all over what? 20 million. That is just an example of how to know that the odds are very high. Sorry, low. Yes, your odds are very low. You understand what I'm saying? So you have less chances of winning. So some of you might still be wondering how to use this probability. Well, that will take us to our next lesson, which is what? Expected values. Expected, let me spell it out. Expected uh expected values. Expected values. Expected values. And don't get me wrong, we are just getting to start with probability. You understand? So we are going more deeper and deeper and deeper. So please, but I'm going to make sure I simplify it to the best of my knowledge. I will simplify everything. So just stay calm. Whatsoever question you may have, contact me on Discord. Write it on Discord. Put it in the comment section if you are still confused. And like I always said, I will never edit my video. If I make any mistakes, I'm making it for you to see so that I can correct it for you to see. I'm not acting movie. I won't do an edited movie, an edited video. I like my video to be raw. If I speak a blunder, yes, I will correct myself right here. If I make an error while coding or while doing anything, I will correct myself here so you will see the correction. So it is better than me doing the behind the scene correction. You will see my correction right here. So for those of you that may not be pleased with me not editing my video, I'm sorry, but I always believe in originality. I always believe in reality. You understand? So I'm trying to paint a picture. I'm trying to create a scenario where I'm right in front of you in the classroom. So don't get offended. I'm sorry if you don't like a non-edited video. I don't like to edit my video. I like to do it raw. I don't like to do behind the scene corrections. I like to do my corrections for you to see. And feel free to comment about my video in the comment section. If you have any question, if you have any query, like write it down in the comment section, or you might just come to the Discord and discuss it. And if you feel you want to be personal about your question, message me directly on the Discord. Thank you very much, and God bless.